So in this case, let's take an example and say we're talking about hockey teams. And I don't know, let's say these baseball players, I should say. Then we want to chart out, figure out if home runs are affecting salary. Well, we would start off with probably just a plot diagram. And can anybody raise their hand, let me know what you think the plot diagram would generally look like? I plotted every player in baseball with that line, or those plots would end up looking like, yes? A positive slope. Positive slope, good. Probably looks something like this.
With a few outliers.
A few outliers, plus a few out here. Right? And very basically, it's just the bare basics right here that I'm going through for those of you that might not be familiar with regression analysis. What we're doing right here is we are trying to determine what this relationship is. And so we plug all this information into a computer, and whatever computer that we decide that we want to use. And the computer computes a line. That line is fitted a certain way. If we were to fit the line this way, it would not be the best fit, because there would be too many over here. Let me start this way. The line is fitted to try to minimize the difference between the residuals and the line. So this, in effect, is a residual. Whatever line ends up minimizing the square root of all the residuals that are added up ends up being what we would call OLS, ordinary least square. That's the method of fitting this line in a proper way. Probably down the road from here, if we're talking about this, we're going to get too far into this, but the method with which you end up using this and fitting this line is called BLUE. Does anybody know what BLUE stands for? Yes.
Linear unbiased estimator.
Correct. Yep. Best linear unbiased estimator. So you use as a general rule called BLUE, best linear unbiased estimator. That BLUE is what you use to fit that regression line. This ends up being a coefficient, it's called beta 1. This ends up being what we would call an intercept, beta 0. So it's very fairly standard, y is equal to mx plus b type of format. You toss it in there, and in fact, that's exactly what we end up doing. Y is equal to mx plus b formula. Y, salary, is equal to our intercept, beta 0, plus our slope, m, beta 1, times whatever our exits, home runs. That, in a very, very quick nutshell, is what a simple regression analysis is. Yes?
Is BLUE the same as the uniform minimum variance unbiased estimator, or is that something different?
Don't know.
Okay.
Sorry.
Okay.
What is it called again?
UMVUE, uniformly minimum variance unbiased estimator.
Don't know. Does anybody else know?
They usually refer to the maximum likelihood, which is, in OS is actually the same in most situations, but in some cases, the maximum likelihood rejection is your better estimator than well.
Right. This is the bare bones. This is called a simple regression analysis. The reason why it is a simple regression analysis is because we have only one dimension that we're spitting out here, home runs. If we wanted to toss in RBIs, on-base percentage, whatever else we think might go into affecting this player's salary, then we have more than one thing. Now all of a sudden we have what we call a multiple regression. Because we would have more than one exit. Because I'm not a very good drawer, I can't draw third dimensional regression analysis. Never actually seen anybody try. I won't bother drawing it up here. If I was that talented, I would try to do that. Spit out another axis, z-axis somewhere here. Try to at least get into the thing. So that's the basics behind regression analysis.
Each independent variable would be another dimension.
Each independent variable, yep, would be another In this case, this is the x-axis, so it would be another x variable.
Another X, like you have like a Z and
And they're all affecting the dependent y variable. In this case, salary. So that's the other thing. We have independent variables and dependent variables.
What would that mean? Okay.
It's called a residual. Basically, it's just a mathematical difference between this line and this plot. Plot talks about the very general relationship between the two variables. The residual is each observation. Each observation's difference between that and the line. It's my understanding that he did not give you anything, any multiple regressions, right? Only gave you simple regression stuff.